This video will show you how to use Excel to compute the confidence interval estimate for proportion. In this example, you have a sample size 500 and 247 out of the sample of 500 responded yes to a survey. And you would like to use this data to estimate the proportion of people who would respond yes in the population using a 95% confidence interval. Okay, so the formula for the confidence interval estimate for proportion is the following. Right? You have a p hat, that's a sample proportion. This will be the 247 out of the 500. Right? Plus or minus z-score associated with confidence level times square root of p hat times 1 minus p hat over n, which is sample size. Okay. To do this, let's open another sheet. Right, so add another sheet called sheet 2. So here I'm going to do some labeling. I'll have a respond that is yes, and I have a respond that are no. So for yes, we have 247, and of course out of 500, if 247 are yes, there will be 253 no. Okay. Now I'm going to do some other labeling. Start with confidence level, column F, that's 0.95, right? 95% confidence level. And I'm going to need the total counts. We're going to make a total count here, and the total count, of course, is equal to sum. I use a sum function to sum these two numbers, right? In Excel, there's a sum function. Sum in the open parentheses, and you just select the range of number you want to sum, right? So I use B1 and B2, right? And next one, I'm going to type in proportion of yes in this survey. So the proportion of yes, that's p hat, that is equal to the 247 divided by 500, that's this B1 information, divided by the F2, right? That would give me 0.494, right? So this number is equal to, again, B1 divided by F2, right? And then the fourth one, I want to have put this information that is two-tail probability. Okay, what this two-tail probability is, actually, when the confidence level is 95%, then what of it, the total tail area outside this 95%. So it'll be 1 minus this 95%, that's 0.05. Okay, so I like that information. I will use that later on. And then I need to find the z-score. Remember confidence interval estimate formula, right? The marginal error part start with the z-score, right? Correspond to 95% confidence level, then times square root of p hat times 1 minus p over n. Okay, so my z-score, I'll label the z-score. What would be my z-score? There's a function in Excel. So I'm going to do equal and normal. Actually, z-score is a standard normal, so I'm going to use a period S, and then inverse. Okay, so I'm going to use this inverse function, and in there it just asks you to specify the probability, and this probability should be the cumulative, right? So cumulative probability for the z-score for one of the endpoints for this confidence interval. This probability will be actually 1 minus this total tail probability divided by 2. So this will give me, in this case, will be 0.975 of this standard normal distribution. Now, if you recall, when we build the confidence interval, the size of the interval is determined by the sampling distribution of the statistic. Now, if I have a 95% confidence interval, then the size of this interval will be an interval that covers center 95% of the sampling distribution. Now, if center has 95%, then total tail area is 0.05 or 5%. And the z-score for this point here, right-hand point here, should have a cumulative distribution 0.975, which is because its right tail area is 0.025. It's half of the 0.05. And that's why in that formula we use 1 minus half of the 0.05, which is 1 minus this 0.025 to get the cumulative distribution at this point, 0.975, and to get the actual z-score we need. So that's how and why when we try to calculate this z-score, right, we use 1 minus half of the 0.05, which is 1 minus 0.025, give me the 0.975 cumulative probability to get that particular z-score. So the next thing, so once we have a z-score, we can calculate the, so that z-score is 1.959. I think you have done this several times for the 95% in the z-score problem is 1.96. Right? The Excel gives you a more precise number. Then the next thing we can find now is the margin of error. Now margin of error, according to the formula, is this z-score times square root of p hat time, that's asterisk, parenthesis 1 minus p hat over sample size, close parenthesis, right? So the margin of error is z-score times square root of p hat times 1 minus p hat over sample size. Again, let's check that formula. Let's look at this formula, right? Square root of p hat times 1 minus p hat over. So that gives us a margin of error is about 4%. Okay. Then we can get the lower bound. The lower bound should be equal to the sample proportion minus the margin of error. Okay. And the upper bound will be equal to, now let's say here on this cell put that lower upper bound that is equal to the proportion of yes plus margin of error. Okay. So I got the lower bound and upper bound. Okay, I got my confidence interval. Now when you report this, you can say this is like 45.02%, right? 0.4502, that's 45.2%, 02%. And then is 53.78%, right? If you report it in interval form, that would be the answer, right? And sometimes people will report in terms of the estimate, 49.4%, and plus margin of error of 4.38%.